Welcome back, guys. Here I am with another session with finding equivalent resistance of different circuits. Now we'll solve one circuit which is pretty uh, interesting one. So the examiner need to find R equivalent. So the terminals are located like this, and he want us to find the R equivalent of this circuit. That means if you have connected a source here, you connect a source here, so the source should look at the equivalent resistance. How to find the equivalent resistance? So representing this entire thing into one point. That is, so we have to represent the total equivalent resistance, that is R equivalent. So we have to find this R equivalent. How you will find? First you have to look at which elements are connected in series parallel combination. So if you observe carefully, this 10 ohm is connected parallel. So how? Since you have this end terminal and this N terminal, so we have to imagine the N terminals. Okay, these N terminals in the N terminal are connected like this. You might have seen in labs. Example, this N terminal in the N terminal connected with one point, and again this end terminal and this N terminal connected with this point. Therefore, these 10 ohms and these 10 ohms are in parallel. So if you want to justify whether other elements are seriously parallel connected, if you see 5 ohm and 10 ohm, if you assume that these two are in series, so the series thing is what? The series means the two elements should have flow one current only, that is I. But if you observe carefully, this middle, the current will diversion is taking. So these 5 ohms, 10 ohms doesn't have equal current. Again, this 5 ohm and this 5 ohm might observe like parallel, but in between you have 10 ohm. So this two N terminals doesn't have one common point. So straight away, if you observe carefully, this 10 ohm are connected in series. So we can represent this circuit in our convenient manner like this. So I am representing like this. This 10 ohm are in parallel. Again, this 5 ohms. So how we will represent after representation or rewriting reducing the circuit? We have to see that the equivalent circuit which you are drawing should not be changing. So this N terminal, say let us say this is A and this is B, N terminals. This A, B should have one common point, that is this one. So if you observe carefully, this N terminal is B and this A. So these 2 points should be common. So B, I am drawing like this, 5 ohm. Okay, so these two circuits are equal. To confuse you, examiner may give like this, but if you keenly observe, you can draw like this. So this 10 ohms are in parallel. So parallel elements means these two are equal elements, though 10 by 2, that is 5 ohms. Replace the 5 ohms here. So the 5 ohm and again 5 ohm, that is 5 ohm. The value of this is 5 ohm. This is 5 ohm. So this 5 ohms are in series. So straight away equate them. Straight away add that. You will get 10 ohms. After getting 10 ohms, just replace the circuit like this. And again now you have, so 5 ohms and 10 ohms are in parallel. Therefore R equivalent can be represented like this: 10 ohm in parallel with 5 ohm. Okay, 10 into 5 by 10 plus 5. So this is the value of 50 by 15. So R equivalent is the value of 50 by 15 ohm. Okay. So what you see is, we reduce the circuit to our convenience, that is 10 ohms and 10 ohms are in parallel. After getting this, the after that, after converting this to this, the sum will be easy. If you straight away see this, you will get confused. So how do you give in? So you need not to draw. So many people will change this star to delta. This is star, and they will connect to delta. If you do, if you can follow that, means it's not a problem. So if you know the formula, if you memorize that formula, you can straight away use that, or you can redraw this. Okay. Now we'll go to other sum. So very interesting one. So if you are if you do many problems, experience it with circuits, after seeing or by seeing straight away you can answer that. But to do these circuits, you need to have some experience. I'll introduce that to you now. So your asking is to find R equivalent. Now from these two terminals you have to see this, and you have to find R equivalent. Now what you observe is which elements are connected in series parallel combination. So if you see carefully, this 10 ohms, 20 ohms having one N terminal, this having one N terminal. So these three elements are having one N terminal. So first we will do these two things. Okay, this 10 ohms and 20 ohms will redraw that. How will we redraw that? That 40 ohms is connected like this, 30 ohms is connected like this, 20 ohm, and this point, and 10 ohms like connected like this. So this point A is replaced like this. So let us say this is a B point, this is A point. So we are having A, this is B, and now B. Okay, so sorry, we'll keep this C. So C and A are equal, and A, or we draw again the circuit. Now these two elements are in parallel. So 10 ohm in parallel with 20 ohm. So what is the value of that? 10 into 20 divided by 10 plus 20. You got about a 6.6 value. So replace that 6.6 with 40 ohms, and you are having 30 ohms. So again A, B. Now observe carefully, these two things are in parallel, right? Or these two things are in parallel. So we write 40 ohm in parallel with 30 ohm. So I am doing this thing. So 40 in parallel with 40, 30, what happened? You got about 17.14. So the circuit is there now. You got this point. This is the thing you're getting. So this, let us say this is D. So you combine these two, and this D point, the wire, it is connected like this. So A, B. Again these two things are in series. We'll add that. So 17.4 plus 6.6, you got the value of 24 ohms. But you are having again this thing. So if you observe carefully, this 24 ohm in parallel with R equal to 0. So the resistance of this wire is 0. That is R equal to 0. Something is parallel with 0 resistance is, will get 0. So 24 into 0 by 24 plus 0. You get value of 0. Therefore, you will observe like this. That is AB. Okay. So R equal to 0. So the equivalent resistance of this circuit, that is R equivalent, equal to 0. So I said before, by straight away looking it, we can find that R equivalent value 0. How? If you observe carefully, this entire circuit can be redrawn like this. Okay, this wire is connected, this 30 ohm, this 40 ohms, 20 ohms, and in 10 ohms, and this 10 ohm. Okay, so by seeing this, what happened here is AB, the equivalent resistance is because 0, because this entire thing is shorted, is 1 point. Okay, so because this having only one shorted, entire thing is shorted, that is, if you don't have this wire, means there will be a provision of equivalent value, some value, but because of this shorting, there is a value of R equivalent equal to 0. Okay, now we'll go to another sum. Now we'll solve one other sum. This is also a pretty interesting one. So the examiner need is the equivalent resistance across AB. Okay, this is 1 ohm, 4 ohm, 6 ohm, and it is 6 ohms, and this is 4 ohms. Let us take 4 ohms, and again 5 ohms. So random value, what are the value? The value is not an important thing, but the actual concept is important. So 10, some any random value I'm taking. Okay, now what do you observe here? So straight away, if you see this 4 ohm, 5 ohm, and 4 ohm are in series. So we'll replace this, and again what you observe, there is a one point here. So if you see the straight line, don't confuse that. You can merge this. Okay, you can merge this, and you will, and you can merge this also. Okay, if you can merge this and you can merge this. If you merging that, what you get is a circuit will be represented like this. And the equivalent resistance values 4, 5 plus 4. What is the value? 9 plus 13. You given 13 ohms, and this is 7 ohm, and merging right. This is 4 ohms, and this is 8 plus 9. What is the 8 plus 9 value? 17, and this is 21. 10 plus 11. Okay, and this is 1 ohm, this is 1 ohm. If you see that, by looking at this, you can straight away say that 8, 9, 17 and 11, 12, 21, this 17 and 21 and this short line are equal to 0 and in parallel. Therefore, this one, something which is parallel with 0 resistance is parallel with any element, then the entire branch will become 0. Or if you see there is any resistance here at this point, no. So this entire thing will become 0. Either way you can represent, say that this point represent, that is, if you see in the circuit, this 12 ohm and this 10 ohm, this no way connected in series or in parallel. So it is shorted by on one point. These two elements are shorted by this line. Therefore, something element which is connected in series in parallel with the 0 resistance means it is 0. And again, if one point having no resistance, therefore this is 0. So we can replace this or transform this circuit, entire circuit like this. This. So all will represent is 4 ohm off, and 2. This combined thing will become 2 ohm, and this combined thing will become 3 ohm. 3 plus 2 is 5 ohm. Represent that, and we are having a 30 ohm, and this entire thing will be represented as a 0. So therefore this is 0, and we are having 4. So this is the thing. So 7, 11. So R equivalent equal to what? R equivalent equal to 1 plus 5 plus 13 plus 7 plus 4 ohm. Okay, finish. And again, I'll do one problem. So straight away I'll explain one thing to you without any delay, or we'll solve directly. So 3 ohm, 9 ohm, and 9 ohm, 9 ohm, 3 ohms. Okay. Now what happens here is, if you want to say series parallel combination, there is no provision of series parallel combination. So 3, 9, like similar way in form of parallel, but they are not parallel. But you have these 3 elements connected in star. So 3, 3, 3 are star. So whenever elements, 3 elements are in star connected, okay, when 3 elements are R, let us say R, when 3 elements are star connected, if you transform that to delta, observe carefully, the multiple of 3, so the value of them is multiple of 3. Observe, they take this as granted. So whenever you are wishing to find something from star to delta to star, let us say this is R value, R value, R value, and we are converting it to star. So the value of star elements is R by 3, R by 3, R by 3. Okay. So star to delta means the resistance of that individual element will be increased. Delta to star means the resistance of the individual element will be divided by 3. Okay. This is the fundamental thing you need to understand. Few circuits will be given to that. If you know these common observations, you can straight away do that. So if you observe carefully, this is connected in star, right? So we need to transform these 3 elements into delta. How you will transform that? So replace these 3 elements with 9 ohms. So multiple of 3 is 9. How will replace that? 9 ohm, this is 9 ohm, and this is 9 ohm. So replacing the element, these 3 elements like this. Let us say this is RA and RB, RC. Okay. So value of RA, RB, RC are 9 ohms. So if you observe carefully, this 9 ohm, this 9 ohm in parallel, this 9 ohm in parallel, this 9 ohm in parallel. So all add them. So combine them, you'll get. So parallel, 2 elements are in parallel, divide by 2. So 5 by 4.5, and this element, this 9 and 9 combined gives a value of 4.5, and this 2 combined gives a 4.5 value. So things got normal now. These 2 elements are in series, you'll do that. So what is the value you get? 9 ohms, and this is 4.5 ohms, and this 2 in parallel, you'll do that, and again come parallel in series. So 3 in series with 4.5 parallel with 9. Okay, finish. So volta, if you something with star element connected in equal L values, you'll do that into delta, and delta value connected in equal values, you'll convert into star. Okay. Now we'll do one more interesting sum. Here is, so when you come to transients, so for EEE guys, the second semester you'll have a transients unit, and for EC guys in first semester you have in second semester you have transients. Now I will give one problem. Here is, so don't get panic. The question is like this: if the guys who have completed the transients, this is very much easy, but the guys who have not yet did transients and all, it will get difficult. This 10 ohms, 10 into million. The question is, find R equivalent for steady state at steady state. Let us say steady state, at steady state, or DC equivalent we'll call. So the DC source is given here at steady state. So source is not given, but at the question is find R equivalent, that is R equivalent at steady state or DC equivalent of the circuit, DC R equivalent of the circuit. So when you see this, if you see, sir, inductor is given and capacitor there, how will you find R equivalent? So at steady state, so whenever you observe the circuit and steady state, inductor is shorted. Okay, inductor is replaced by a short circuit and the capacitor is replaced by open circuit. Okay, why? The reason is I'll explain later. Okay, so straight away replace the inductor. Wherever you see the inductors, you replace one short circuit wire. So this inductor is replaced by a short circuit. This 10 ohm, and this capacitor is replaced by open circuit. So this is the thing. So we converted this circuit to a equivalent DC circuit. That is steady state. At steady state, the inductor behaves as a short circuit and the capacitor behaves as an open circuit. So after replacing these two, inductor and capacitor, we got this circuit. So if you observe carefully, these 10 ohms are in series, are in parallel. Okay, and the rest of thing will get common. So this 5 ohms is not connected to anywhere, thus we neglect this resistor. So replacing the circuit, this 10 ohm, so this can be replaced like this. So 5 ohms and this is 4 ohms. So R equivalent equal to what? 5 plus 4. So you got 9 ohm. Okay. So if you find any difficulty questions in finding R equivalent, just ping me. I given my number, that is 9030 364514. So call me or ping me in WhatsApp and I'll be answering you. Thank you guys.